In 1943, this was a death sentence. A simple cut, a piece of shrapnel, infection was a greater killer than the bullet. Surgeons had only one real tool, the saw. But on the front lines, medics watched in stunned disbelief as a strange, mouldy substance began doing the impossible. It was stopping certain death in its tracks. This is the story of the one weapon in World War II that wasn't designed to kill, but to save. February 14th, 1943. A dusty clearing 5 miles west of the Kasserine Pass, Tunisia. The air inside Tent 3 of the casualty clearing station doesn't just smell bad, it smells ancient. It's a thick, sweet, rotten odor that clings to the back of the throat, the smell of gas gangrene. Outside, the Afrika Korps and the Green American divisions are locked in a brutal struggle for the pass. But in here, the enemy is different. It's silent, invisible, and it is winning. Captain Elias Thorne of the Royal Army Medical Corps leans over a canvas cot. His khaki sleeves are rolled up past the elbow, his forearms slick with a film of sweat, sand, and iodine. The canvas flaps of the tent snap and crack in the gritty desert wind, pulsing the dim light and sending fine particles of sand onto everything. The instruments, the cots, and into the open wounds. On the cot lies Private Shaw, 19 years old. He wasn't hit by a Panzer shell. He didn't step on a mine. 2 days ago, during a retreat, he'd scrambled over a sun-baked stone wall and a piece of rusted farm equipment had torn his thigh open to the bone. Now, that leg is unrecognizable. It's swollen to twice its normal size, the skin a grotesque purple-black, weeping a foul brownish fluid. Red line streaks of lymphangitis track up from the wound toward his groin. Shaw is shivering violently, his teeth chattering, though the air in the tent is over 100 degrees. He's delirious, muttering about a girl in Leeds. Thorne presses a gloved finger near the wound's edge. The tissue crackles, like popping paper. Crepitus. Gas, produced by the bacteria Clostridium perfringens, is literally fermenting the muscle beneath the skin. This is the reality of military medicine in 1943. This is the war behind the war. Thorne looks at his orderly, Corporal Davies, whose face is pale beneath a mask of grime. "The sulphur?" Thorne asks, his voice flat. Davies just shakes his head. They'd packed the wound with their only wonder drug, sulfanilamide powder. It was like throwing dust at a tank. The infection had laughed at it. "Get the saw," Thorne says, not as a question, but as a death sentence. This is his only option. Debridement cutting away the dead, black-edged tissue is useless now. The infection is in the bloodstream. Sepsis. The only chance, the slimmest, most brutal chance, is amputation. High on the hip. Even then, Thorne knows, Shaw will likely be dead from shock or systemic infection before the sun sets. This is what medics on the front line faced. The grim calculus of infection. It wasn't the bullet that killed most men. It was the dirt on the bullet. It was the rich, fertilized soil of the European fields or the bacteria-laden sand of the desert, driven deep into tissue by a 5-cent piece of shrapnel. Thorne moves to the next cot. A sergeant from an American tank destroyer battalion. A gut wound. Shrapnel from an 88mm shell had torn through his abdomen 24 hours ago. The sergeant is quiet, his skin pale and clammy. His belly is rigid as a board, peritonitis. His own intestinal bacteria are now loose, poisoning him from within. Thorne simply lifts the corner of the thin grey blanket and pulls it over the man's face. There is nothing to be done. Nothing in his medical kit, nothing in the world, can stop it. This is the surgeon's horror. He is helpless. He can set bones. He can clamp arteries. He can stitch skin. But he cannot stop the bacteria. A compound fracture, where the bone breaks the skin, is a coin toss for survival. A deep wound to the chest or abdomen is a near-certain death, not from the initial trauma, but from the unstoppable infection that blooms 2 days later. The aid station is a butcher's shop ruled by 3 brutal principles: irrigation, debridement, and amputation. Flush it with saline, cut away what you can, and saw off the rest. Captain Thorne strips his gloves and throws them in a bucket. He is losing this battle. He is fighting a 20th century war with 19th century medicine. He has no idea that halfway across the world, in the sterile quiet of laboratories, a small team of scientists is looking at something found on a rotting piece of fruit, a simple mould, and in that mould, they are finding a weapon that will change his world, and the fate of men like Private Shaw, forever. But here, in the stink and heat of the Kasserine Pass, that miracle is an ocean away. There is only the scalpel, the saw, and the relentless invisible enemy. September 3rd, 1928. St. Mary's Hospital, London. The laboratory of Dr. Alexander Fleming is a chaotic landscape of glass. Petri dishes, beakers, and test tubes clutter every workbench, stacked in precarious towers. Fleming, a quiet, observant bacteriologist for the inoculation department, has just returned from a 2-week holiday. His bench is exactly as he left it, a mess. On it sits a stack of shallow glass dishes he'd been using to grow cultures of Staphylococcus, the bacteria responsible for boils, abscesses, and a host of septic infections. Before leaving, he'd set them aside to be cleaned. Now, he picks one up, intending to drop it into a bath of Lysol. But he stops. He squints through his spectacles. Something is wrong. Or rather, something is different. The dish has been contaminated. A fuzzy, blue-green patch of mould, identical to the kind that ruins bread or cheese, has blossomed on one side of the culture. This is a common and intensely annoying failure in a lab. A ruined experiment. But Fleming looks closer. He isn't a tidy man, but he is a brilliant observer. In the areas near the mould, the golden yellow colonies of Staphylococcus are gone. Not just inhibited, but destroyed. They look like they've been dissolved, leaving a clear, bacteria-free ring. A zone of inhibition. That's funny, he mutters to his assistant. He immediately recognizes the implication. The mould is secreting something. A mould juice, as he first calls it, that is a lethal enemy to the bacteria. He identifies the mould as Penicillium notatum. He names its potent bacteria-killing secretion, penicillin. Fleming has just discovered the single most important weapon of the 20th century. And for the next 10 years, almost nothing happens. Fleming is a bacteriologist, not a chemist. He tries to work with the juice, but it's maddeningly unstable. He can't isolate the active ingredient. He can't purify it. He can't even keep it potent for more than a few days. He tries it on a few surface infections, but the crude, unpurified liquid is too weak to have much effect. In 1929, he publishes his findings in a medical journal. The paper receives almost no attention. It is a scientific curiosity, a footnote. The miracle sits on a shelf, a ghost in the medical literature, while the world marches toward another war. September 1940. The Sir William Dunn School of Pathology, Oxford. The Luftwaffe is tearing the heart out of London. The Blitz is raging. The war is no longer a distant threat, it is screaming overhead. Inside the cramped, stone-walled laboratories, the air is thick with the smell of a damp cellar. This is the new front line. Dr. Howard Florey, a pragmatic and driven Australian pathologist, and Dr. Ernst, a brilliant Jewish-German biochemist who fled the Nazis, have resurrected Fleming's forgotten paper. The war has given their research a desperate, terrible urgency. They know what sulfur drugs can, and, more importantly, cannot do. They are hunting for a true antibacterial weapon. They are not just researchers. They are mould farmers. Their lab looks less like a high-tech facility and more like a Depression-era pantry. They are growing penicillium in anything they can get their hands on. Biscuit tins, milk churns, ceramic bedpans borrowed from the Radcliffe Infirmary. Every container holds a shallow layer of nutrient broth, and floating on top is a velvety blue-green mat of mould. The work is agonizing. The mould weeps its penicillin into the broth, but the concentration is infinitesimal. It's like trying to extract a single drop of perfume from a swimming pool. Their colleague, biologist Dr. Norman Heatley, has become a master of improvisation, building a makeshift purification machine out of dairy equipment and porcelain piping. They use ether, volatile, flammable liquid to extract the precious chemical. The entire lab is a fire trap, reeking of chemicals and mould, They finally produce a tiny pinprick of brownish-yellow powder. It is impure, unstable, but it is penicillin. On May 25th, 1940, they conduct the crucial test. They infect 8 mice with a lethal dose of streptococcus. 4 are left as a control. 4 are given injections of the brown powder. The next morning, Florey and Chain return to the lab. The 4 untreated mice are dead. The 4 mice treated with penicillin are alive and well. Chain would later say they danced a little jig around the lab. They have done it. They have proven Fleming's mould juice can fight a systemic infection. But their victory is hollow. They look at the microscopic scraping of powder they have left. To treat a single human soldier, just once, they would need 2,000 litres of the mould broth. They are staring at a miracle they cannot produce. The war is consuming millions, and they have a cure that can only save mice. The Blitz is intensifying. Invasion seems imminent. If they are to turn this lab curiosity into a war-winning weapon, they need to scale up, and they need to do it somewhere the bombs can't reach. They need an entire industry. They need America. July 2nd, 1941. Peoria, Illinois. The heat is a physical weight, thick and wet, rising off the endless Illinois cornfields. Dr. Howard, Florey, and Dr. Norman Heatley have traded the London Blitz for the American Midwest. They carry no state secrets, no battle plans. Their entire hope is contained in a small glass vial, carried in a coat pocket. Inside, dried spores of Penicillium notatum. They have crossed a U-boat-infested ocean, convincing a skeptical US government to help them. Their journey ends here, at the USDA's Northern Regional Research Laboratory in Peoria. Why Peoria? Because this lab knows fermentation. It knows how to make industrial products from agricultural crops. And crucially, it has deep tank fermenters for experiments. Dr. Andrew Moyer, the lab's head of fermentation, greets them. He listens to their story of the Oxford bedpans, the weak yields, the desperate need for more. Moyer understands the problem isn't just about medicine, it's about production. The Oxford strain is finicky. It only grows on the surface of the broth. It's like trying to harvest wheat one stalk at a time. They need a better mould, and they need a better way to feed it. The great mould hunt begins. The US Army Air Transport Command is given a strange new directive. Pilots flying missions across the globe are ordered to scrape mould off anything and everything. They bring back samples from jungle rot in Burma, from spoiled food in China, from contaminated cheese in Egypt. The lab in Peoria is inundated with fungus. But the hero of this story isn't a pilot or a general. It's a lab technician at the Peoria facility named Mary K. Hunt. Her job, which she performs with relentless enthusiasm, is to find and culture new mould samples. The staff affectionately calls her Moldy Mary. One summer afternoon in 1943, Mary is at a local grocery market and finds a cantaloupe. It's not just spoiled, it's spectacularly spoiled, covered in a pretty golden fuzz. Fascinated, she takes it back to the lab. It's not Penicillium notatum, it's a different species entirely, Penicillium chrysogenum. When they culture it, the lab technicians can't believe the readings. This cantaloupe mould is aggressive, robust. It produces 200 times more penicillin than Fleming's original strain. But the true breakthrough, the secret that unlocks the industrial miracle, comes from Moyer's team. They need to find the perfect food for this new super mould. They try hundreds of combinations. Nothing works well enough. Then, Moyer has an idea. He looks at the local economy. Peoria is a corn town. One of the largest local industries, the Corn Products Company, produces starch and a lot of waste. That waste is a thick, nutrient-rich sludge called corn steep liquor. It's cheap, abundant, and considered useless. They add the corn steep liquor to the fermentation vats. The result is explosive. The combination of Mary's cantaloupe mould P, chrysogenum, and Moyer's corn steep liquor is the magic formula. The mould doesn't just grow on the surface, it thrives deep within the vats, turning the entire mixture into a frothing penicillin-producing soup. The yield isn't just double, it's not 100 times more, it is 1,000 times greater than what Florey and Chain were getting in their bedpans. This changes everything. This is the industrial key. The War Production Board steps in. This is no longer a science experiment. It is a strategic imperative, given the same priority as the Manhattan Project. Pharmaceutical companies like Pfizer, Merck, Squibb, and Abbott are ordered to convert their factories. Pfizer, which specialized in citric acid fermentation, is perfectly positioned. They stop making drink additives and start making medicine. In Brooklyn and New Jersey, giant 20,000-gallon steel vats are built, towering 3 stories high. They are filled with Moyer's corn-steep soup, sterilized, and then seeded with the spores of a mould found on a Peoria cantaloupe. Huge compressors pump sterile air into the bubbling, frothing mixture, 24 hours a day. In 1941, the total US supply of penicillin was enough to treat perhaps 10 people. By 1943, they are producing 21 billion units. By 1944, for the D-Day landings, they will have produced 2.3 million doses. The mould juice is now a weapon. It's being freeze-dried, powdered, put into vials, and packed into wooden crates. And those crates are being loaded onto C-47 transport planes, flying the same ocean Florey crossed with a single vial in his pocket. The miracle is finally heading back to the war. It's heading for men like Captain Elias Thorne, January 24th, 1944, a casualty clearing station near Anzio, Italy. It is cold. A bone-aching, wet Italian winter cold that penetrates the canvas tents and turns the mud outside into a frozen, boot-sucking slurry. Captain Elias Thorne, his face now etched with the lines of another year of war, is here. Kasserine was a lifetime ago. Now, he's dealing with the fallout of Operation Shingle, the brutal beachhead landings at Anzio. The fighting is savage, and the wounds are horrific. The Germans are shelling the beachhead relentlessly. Worse, the battlefield is the reclaimed Pontine marshes. The soil is fertile, wet, and thick with farm animal waste. It is the perfect breeding ground for Clostridium and Staphylococcus. Every shrapnel wound arrives at his tent pre-infected. Thorne is triaging a new wave of casualties from a counterattack. A corporal is wheeled in on a stretcher, his left leg wrapped in a blood-soaked, filthy blanket. He has a compound fracture of the femur, courtesy of a mortar fragment. He's been lying in a ditch for 8 hours. Thorne doesn't even need to unwrap the wound to know. The smell is already there. The faint, sweet, rotten signature of gas gangrene. He sees the grey, waxy pallor of sepsis on the man's face. He is 20 years old. He is, in Thorne's experienced and weary estimation, already dead. Put him in the corner, Thorne says to his orderly, Corporal Davies, who has been with him since Africa. The corner is where they put the moribundith men who are too far gone to waste resources on. We'll take the leg in an hour, if he's still with us. Try to make him comfortable. As Davies wheels the corporal away, a jeep splashes to a halt outside. A young American medical officer, a major, hurries in, shaking the rain from his coat. He's carrying a wooden crate stenciled with a red cross and the word, experimental, refrigerate. Captain Thorne? The major asks, his voice full of an unwelcome, clean world enthusiasm. Just came up from Naples. You're the new priority recipients. He pries the lid off the crate. Inside, nestled in straw, are small glass vials filled with a mustard-yellow powder. What is it? Thorne asks, not looking up from a different patient. Penicillin. Sir. Thorne has heard the word. A rumour from a medical journal. The mould juice. Is it any better than the sulphur? They say it is, the major says, picking up a vial. A lot better. The instructions say it's for systemic infections. Sepsis. Gangrene. Compound fractures. Thorne finally looks at him. He is skeptical. He has been given miracle cures before. They always fail. How? Intramuscular injection. 3-hour intervals. You have to mix the powder with saline first. An injection. Not a powder on the wound, but a drug inside the man. Thorne looks at the vials, then looks over at the corporal in the corner, who has begun to shiver violently. He's a lost cause, Major. That's gas gangrene. He'll be dead by morning. Then he's the perfect test case, isn't he? The major replies, holding out a vial. Thorne hesitates. He is a surgeon. He believes in the clean cut, the scalpel, the tourniquet. This feels like alchemy. But he also sees the face of Private Shaw back in Tunisia. He sees the hundreds of men he has lost not to the trauma, but to the bacteria. Davies. Thorne barks. Bring a syringe. And some saline. We're trying the bloody mould juice. They mix the yellow powder. It dissolves into a cloudy, amber-coloured liquid. It looks crude, dirty. Thorne fills the syringe, walks over to the corporal in the corner, and slides the needle into the man's shoulder. The soldier doesn't even flinch. Thorne administers a second dose 3 hours later, in the dead of night, by the dim light of a kerosene lamp. The man is still breathing, but his pulse is a fast, thready whisper. Thorne goes to his own cot, convinced he is wasting his time. At 0600, Thorne is woken by Corporal Davies, who is shaking his shoulder. "Sir, you need to see this." Davies's voice is trembling. Thorne scrubs his face with cold water and walks into the pre-op tent. He prepares himself for the sight of the dead corporal. He stops. The corporal is not dead. He is awake. His eyes are lucid. The violent, septic shivering has stopped. What's happening?" Thorne whispers, walking to the cot. He pulls back the filthy blanket. The leg is still a mangled ruin of flesh and bone, but the smell, the overwhelming putrid stench of gangrene, is gone. The swelling has visibly reduced. The terrifying purple-black colour of the skin has faded, and the angry red lines tracking up his thigh have vanished. Thorne presses a finger near the wound. The crackling crepitus, the gas under the skin, is gone. He looks at Davies. Davies is pale. "I took his temperature, sir. It's down, from 104 to 99. Thorne feels a cold prickle on the back of his neck. This is not possible. This is not medicine. This is a resurrection. He has just seen a man pulled back from the absolute brink of septic death, not by a scalpel or a saw, but by a few injections of yellow powder. It worked," Thorne says, his voice breaking. He picks up the vial, staring at it. It actually worked. He turns, his mind racing. He thinks of the man with the gut wound in Africa. He thinks of the pneumonia ward. He thinks of every amputation he ever performed to get ahead of the infection. He looks at the rows of other wounded men in his tent. A soldier with a chest wound, his breathing shallow and rattling. A sergeant with a shrapnel-torn arm, his fever climbing. "Davies," Thorne says, his voice now hard, urgent. "Get more syringes. Get all the saline. We're giving this to everyone." The war, for Captain Elias Thorne, has just changed. The saw was no longer his primary tool. This Moldy discovery was. February 18th, 1944. The Anzio beachhead. The snap of sniper fire and the distant crumping thud of German artillery are the soundtrack to a medical revolution. Inside Captain Thorne's tent, the atmosphere has changed. The suffocating odour of gangrene and sepsis, a smell he had lived with for years, is gone. It has been replaced by the sharp, clean bite of antiseptic and the faint, bready smell of the mould itself. Thorne is doing the impossible. He stands over a soldier with an abdominal wound. Shrapnel has torn through the man's lower intestine, riddling it with at least a dozen small perforations. In 1943, at Kasserine, Thorne would have administered morphine, marked the man's chart with an M, and moved on. The man would have been dead from peritonitis in 48 hours, his belly rigid as a steel drum. Now, Thorne is operating. His gloves are deep inside the man's abdominal cavity. With a fine suture needle, he is patiently, methodically, closing each perforation. This is a delicate, time-consuming surgery he would have called madness just a month ago. A complete waste of time. Why? Because the real enemy wasn't the shrapnel hole. It was the E. coli and bacteroides now flooding the man's peritoneum. But as Thorne works, Corporal Davies stands ready, not with a saw, but with a syringe of the cloudy, yellow penicillin solution. "Now," Thorne says, without looking up. Davies injects the solution into the patient's hip. Another dose is already waiting, ready to be dripped directly into the man's abdominal cavity before Thorne closes him up. This is the new reality. Penicillin has not just given them a cure, it has given them time. It has given the surgeon the audacity to try. The drug creates a chemical shield, holding the bacteria at bay, giving the body's own immune system a chance to fight, and the surgeon's stitches a chance to hold. The shock, for medics like Thorne, is profound. It's a complete inversion of their entire medical philosophy. For years, their doctrine was one of radical, aggressive removal. Debridement. Cut away all tissue that might be infected. Amputate the limb to save the life. The scalpel and the saw were instruments of speed and subtraction. Now, their primary tool is an instrument of addition, the hypodermic needle. The results are staggering. In World War I, a soldier with a compound fracture of the femur had a 75% chance of losing the leg. Now, at Anzio, if he gets penicillin, his chance of recovery is over 90%. Pneumonia, which had killed more soldiers than gas in the last war, is now a treatable illness. Meningitis, strep throat, syphilis and gonorrhea, which ravaged divisions off the line, are cured in a matter of days. But the miracle brings a new, terrible burden: scarcity. The factories in America are roaring, but the demand is infinite. The front lines in Italy, the bombing crews flying from England, the campaign in Burma, the sailors on destroyers in the Pacific, everyone needs it, and there simply isn't enough. The wooden crate of vials that arrives each week is now the most valuable asset in the entire medical station. It is guarded 247, not by a medic, but by an armed military policeman. The American major who delivered the first batch is now known as the Penicillin officer. He carries a ledger and a sidearm, and with that ledger comes a new, colder calculus. Thorne finds himself in a new kind of triage. Before, his decisions were medical. Who is too far gone? Who can be saved? Now, his decisions are strategic. Who is worth the penicillin? A directive has come down from Allied High Command. Penicillin is a strategic asset, to be used only to preserve fighting strength. A new casualty is brought in. A tank driver, 20 years old, his arm mangled by a direct hit. The wound is septic. He needs the drug. Minutes later, a high-ranking staff colonel is brought in. He slipped on wet steps and has a bad case of pneumonia. Thorne, the major, and the head surgeon must decide. The tank driver is a Category 1 wounder, will be out of the war for good. The colonel, if cured, can be back at his desk in a week. The colonel gets the penicillin. The tank driver loses his arm. This is the brutal logic of the new medicine. The drug is reserved for the salvageable soldier, the one who can be returned to duty. The drug is so precious that it leads to one of the strangest directives of the war. Doctors discovered that up to 80% of a penicillin dose is excreted, unchanged, in the patient's urine. The miracle is literally being poured into buckets and bedpans. So, they start recycling it. In military hospitals, orderlies are given the grim task of collecting the urine from penicillin-treated patients. The vats of urine are then sent to field labs, where chemists filter, re-extract, and purify the penicillin, putting it right back into vials to be injected into the next man. For Thorne, the war has become a surreal dream. He is performing surgical miracles he couldn't have imagined, all while his orderlies are farming the mould juice from his patient's waste. All of this, the successes, the failures, the brutal rationing is being watched. Every report, every recovery rate, every amputee saved is being logged and sent back to SHAEF, the supreme headquarters of the Allied Expeditionary Force. The generals in England, planning the largest amphibious invasion in human history, are no longer just counting tanks, planes, and landing craft. They are counting vials. The entire medical plan for D-Day, the survival of tens of thousands of men, is being built on the assumption that the factories in Peoria and Brooklyn will deliver. The Moldy discovery isn't just saving soldiers, it's about to become the essential ingredient for the liberation of Europe. June 9th, 1944. An apple orchard 3 miles inland from Omaha Beach. The air is a concussive soup of noise. The constant metallic screech of German Nebelwerfer rockets moaning minis is followed by the ground-shaking crump of their explosions. The surgical tents of the 91st Field Hospital have been set up in a grid, their canvas tops stretched beneath the shattered branches of the orchard. Captain Joseph Levine, a surgeon with the U.S. Army Medical Corps, has not slept in 48 hours. He is standing in a sea of stretchers. They are laid out in neat, terrible rows that stretch all the way back to the dirt road. The wounded from the fight for Saint-Lô are pouring in. But this is not Kasserine. This is not Anzio. This is D-Day. And the medical plan is as massive and complex as the invasion itself. Levine moves to the next man. A private from the 29th Infantry Division. A piece of shrapnel from an S mine has ripped his thigh open, shattering the femur. The wound is packed with the rich, dark, fertilized soil of a Normandy pasture. In any other war, at any other time, this soldier is a dead man, or, if he's impossibly lucky, he will face a high hip amputation. Levine doesn't even hesitate. He is not fighting the same war as Elias Thorne. He has been trained for this moment. Plasma, he snaps to a corpsman. To another, tag him for pre-op, and give him the shot. The corpsman doesn't ask which shot. He pulls out a pre-filled syringe of the yellow penicillin solution. The private gets the injection right there, in the mud, before he is even wheeled into the tent. This is the difference. This is the miracle of Peoria. Penicillin is not experimental. It is not a last resort. It is protocol. The 2.3 million doses stockpiled for Operation Overlord are flowing onto the beaches with the ammunition and the K rations. Every medic in every unit carries it. Every wounded man gets it prophylactically as a preventative shield before the bacteria can even establish a beachhead. Levine moves into the surgical tent. The scene inside is not one of frantic butchery, but of methodical, confident repair. A young surgeon next to him is working on a soldier with multiple gunshot wounds to the stomach from an MG42. He is doing the same impossible abdominal surgery that Thorne pioneered in Italy. Here, it is routine. Levine can take his time. He can irrigate the private's wound, meticulously removing every speck of dirt, every fragment of uniform, every splinter of bone. He can drill steel pins into the femur to set it. He is not just saving a life, he is saving a limb. He is not racing against gangrene. The penicillin shot has bought him that time. The drug has fundamentally altered the entire chain of evacuation. The massive landing ships, tank LSTs, that brought the 1st Infantry Division to the beach are now being repurposed as wound ferries. The private, his legs set and his veins full of the mould, is loaded back onto an LST. He will spend 12 hours on a stretcher in the damp, diesel-fumed hold of the ship as it crosses the English Channel. In 1917, this journey would have been a death sentence. The man's wound would have festered, and he would have been dead from gas gangrene before they reached Southampton. But in 1944, he arrives alive. He is met by an ambulance and taken to a full hospital, where a surgeon, working in a clean, well-lit operating theatre, will be shocked to find a grievous wound with almost no infection. The statistics are so staggering, they are almost unbelievable. In World War I, the death rate from pneumonia in a military hospital was 18%. In World War II, thanks to penicillin, it is less than 1%. The battlefield survivability rate the chance of a soldier surviving his wounds if he made it to a medic source to over 95%, and the drug is fighting a second war. Allied command knew that once their men hit cities like Cherbourg and later Paris, venereal disease would skyrocket. In Italy, some divisions had lost more man-hours to gonorrhea and syphilis than to combat. Penicillin changed that. A soldier could be diagnosed, given a shot, and be back on the line in 24 hours. The Wehrmacht, which relied on the older, slower sulfur drugs, could not match this. The yellow magic was keeping entire divisions at full fighting strength. Captain Levine steps out of the tent for a moment, wiping the sweat and blood from his face. He looks at the rows of wounded, waiting for the LSTs. They are in pain, they are broken, but they are alive. He thinks of his father, a medic in the Great War, who had described the gas gangrene wards as the anteroom of hell, a place defined by the stench of rot and the sound of the saw. Levine listens. He hears the artillery, the shouts, the trucks, But he does not hear the saw, and the air, though thick with mud and diesel, does not smell of death. It smells of hope. The mould that Fleming found by accident has become the invisible shield protecting the entire Allied army. April 16, 1945. A converted schoolhouse outside Magdeburg, Germany. The war in Europe is in its death throes. The sound of artillery is the sound of the Red Army approaching from the east and the Americans closing from the west. Major Elias Thorne, no longer a captain, stands in what was once a gymnasium. It is now Ward C of the 121st Evacuation Hospital. The cots are filled with a mix of American GIs, German Volkssturm prisoners, and skeletal, hollow-eyed civilians freed from a nearby labor camp. Thorne is doing a final round. He stops at the cot of a German Stabsdienst surgeon named Pieter Grau, who had been captured 2 days ago. Grau himself has a piece of shrapnel in his shoulder, and he's been watching the American medics work with a silent, baffled intensity. His wound, which by his own training should be inflamed and feverish, feels fine. He was given a shot of the yellow powder upon arrival. "You," Grau says in halting English, pointing a shaky finger at an American soldier in the next cot. The GI has a massive stitched wound on his abdomen. He should be dead. Thorne looks at the GI's chart. Gut wound, perforated colon. We operated 24 hours ago. He'll be fine. His fever's already broken. "No," Grau insists, trying to sit up. "It is not possible. The peritonitis. It is absolute. You cannot stop it. We tried with the sulfonamides. It does not work." Thorne nods, understanding. He picks up a small, empty glass vial from a tray. "You didn't have this, did you?" "We heard rumors," Grau whispers. "A mould juice. We thought it was propaganda. A fantasy. Our chemists, they said it was too unstable." "It was," Thorne says, remembering the long-gone skepticism he himself felt at Anzio. "But we made it stable. We made tons of it." He watches the German surgeon's face. He sees the shock he once felt, now reflected in the eyes of his enemy. Grau is not just looking at a superior medicine. He is looking at a strategic gap so vast, it is almost supernatural. The Allies hadn't just defeated the Wehrmacht with tanks and planes. They had defeated their oldest, most relentless enemy, Streptococcus, Staphylococcus, Clostridium. Grau slumps back, a look of profound, crushing defeat on his face. He finally understands. He wasn't just fighting a two-front war, he was fighting in a different medical century. The war ends. The guns fall silent. The world emerges, blinking, from the rubble. In Stockholm, on December 10th, 1945, Alexander Fleming, Howard Florey, and Ernst jointly accept the Nobel Prize in Physiology or Medicine. Fleming, in his speech, gives the quiet, solemn warning that the bacteria could one day fight back, developing resistance if the drug is overused. But for now, the victory is absolute. The secret is out. The word penicillin is no longer a military code. It is a global headline. The massive factories in America, no longer bound by the War Production Board, turn their full, incredible capacity toward the civilian world. The price plummets. What cost $20 per dose in 1943 is available for 55 cents by 1946. And with that, the true revolution begins. The one that goes far beyond the battlefield. Every single medical advancement of the next 80 years is built on the foundation of what happened in those fermentation vats. Open heart surgery, organ transplants, chemotherapy, joint replacements, even routine dental work. None are possible in a pre-penicillin world because the risk of a fatal post-operative infection is too high. The Moldy discovery, which began as a forgotten note in Fleming's lab, which was scaled by Florey and Chain's desperation, and which was industrialized by a cantaloupe in Peoria, has now remade the human experience. The shock that medics like Elias Thorne felt in the tents at Anzio echoes down through the decades. It's the shock of a 19-year-old in 1950 surviving meningitis. It's the shock of a mother in 1960 surviving childbirth after a C-section. It's the shock of a world where a simple cut is no longer a potential death sentence. The Second World War was the most destructive conflict in human history, a story defined by death and destruction. But hidden inside that story is this, the story of a weapon designed only to heal. It saved more lives on the battlefield than any bullet or bomb ever took. It wasn't just a new drug. It was the dawn of the antibiotic age. The war against the invisible enemy had been won.